is the control panel for the Multiceptor test unit down in Fontana, California. Notice the lights that are there. Those lights are indicators of which pumps are running. The two pumps on the right, you now see the green light in the middle. That's just showing the sprayer pump number 3 is running. And as each pump activates, those lights come on for the run cycle time of the pump. The two red lights on the bottom are pump alarm, showing we have a problem with a pump. On the left side and on the right side is a high water alarm and a low water alarm indicator. The light on top shows there's power to the control panel. The red knob on the bottom allows us to silence the audible alarm that comes on when a pump down or a high water alarm or low water alarm event takes place. You can silence the audible alarm with that red button. This is a NEMA 4 control panel. Usually systems can be mounted outside or inside. We do have them mounted on. We do have them mounted in facilities outside the structures, and a lot of times they're mounted inside maintenance buildings where service areas and maintenance people are, so they can be heard when an alarm goes off. This is the inside. It shows the starter motors, the logic system that gives us the indicators and tells us what's going on with the pumps, gives us a visual reading. You can see some writing there now about setting programs and stuff. These are the controls that are used. It has its own breaker system that sets the power down to the system. It also has a separate breaker that intercepts from the power being supplied to the system, so we have our own source of power. Not interfere with anybody else's power. This is our supply unit. This is just water being sent to the system to create a similar to a flow, a passive flow system on a regular sewer line. We can pump 190 gallons a minute into the sewer system, which is what you see happening right there. You see our sprayers are active, working inside the tanks right now. Okay, I don't know if you can see the water right now, but this is passive flow coming from the tank. The water flowing out, and then I'm going to show you a grinder event when the grinders kick on here. This is regular flow system coming in the tank. As much water as you see flowing out is what's flowing in on the other end. And comes into the second chamber through the baffle wall, comes over the crossover pipe, comes in and comes up through this sanitary tee, going out the discharge line of the tank, and then going into the sampling box. Going down, goes through the sampling box to the cross pipe. This is our discharge line from this is our grinder line that comes into the system from our grinder pump. When that water kicks on, I'll show you the velocity increase and the aeration of the water. So it actually helps reduce aqueous hydrogen sulfide because we're re-aerating the water, not letting it go to sulfuric acid. And this is the 8-inch line that returns back to our reservoir tank and sends the water through the system. Now this is the activity of the water when the grinders are kicking on. They're going through the sampling boxes. Notice the air bubbles all through it and the air being blended into it. Not much more velocity increase. It's definitely not under pressure because the pipe's not being filled. So that's what comes up out of this line. Nothing goes back to the blowback or the pressure relief. That's all it is reduced head pressure. Nothing's being discharged out of that line at all. Our sprayer system's working. Overhead sprayer system's working. But again, that's what's incorporated and designed to do. There's our sensor unit all set up, covered up now. Again, this is the whole system completed with manhole covers, risers. In a normal event, all those manholes would be at the same level, but not here on this system because it was too hard to pull them off without falling off the tanks.